Hello everyone and welcome back to the promised tutorial on Pandas. First of all, what is Pandas? Well, it's basically just Excel but for Python, and it's better, faster, and cleaner to use. You're really going to like it because you're going to feel like you have so much power at your fingertips, while in Excel you're just going to have to use your mouse scrolling over and over, then dragging, writing formulas all over the place and just banging your head when it's not working. So trust me, use Pandas, and it's going to be very useful when you're handling spreadsheet-like formats such as Excels, CSV files, or tab-separated values. To install Pandas, you can either use cont'd or pip. So if you have a cont'd environment, I can show how to set it up in this video. You can simply do cont'd install Pandas. If you don't have it and just have normal Python, you just need to do pip install Pandas to install it, and you can verify its version by just simply opening up a Python shell and just doing import pandas._version_, and you're done. So right now I'm currently on version 1.3.4. So currently I just opened Jupyter Lab because it's going to be easier to demonstrate Pandas for you. So as you can see here, if I run this, it just shows what the cell is, and we're first going to cover how we can read files in Pandas. There's two main functions you can use, which is read CSV and read Excel. Read CSV will read, well, from a CSV or just from anything separated by a delimiter. Read Excel is made specifically for, well, Excel files. So if you look at this one, I have a file called winequalityred.csv, and it's separated by semicolons. And so if I read it that way, you see, I get my beautiful data frame with columns here and, rows over here. So you can do a lot of stuff with it, such as looking at its head, at its tail, describing it, and going through its column. If I just assign this to a variable such as df, well, I can just do df.head, and it shows me the first 5 elements. And if I do df.tail, well, now this shows me the last 5 elements. And I can also do df.describe, and it will show me, for example, how many counts do I have in each samples, what is the mean for each column, what is its standard deviation, the minimum, as well as the maximum. And finally, if I want to get a list of the columns just like this, I can do df.columns, and I'll just get a list of the columns themselves. You can also visualize the data frames by using something called the DataFrame.hist, and you can pass in a fixed size such as 15 to 20 to make it look bigger, because the default one will look very squished and ugly. So you can do df.hist fixed size equal 15 20 to get a histogram of each column and see what it looks like. So for example, you'll be able to determine if there are outliers in your dataset or if they all follow a beautiful smooth bell curve. Otherwise, you can show a scatter matrix of each row interaction, or each column interaction, I mean. So for example, here you can see I'm going to plot each feature, like fixed acidity with alcohol. I know it's very small, but just trust me, the text is there, and it's just going to say for each feature and another feature, let's plot their points, and you will be able to see if there's any meaningful correlations. So for example, this mini plot here, you can show that it has like something like an upward trend. Well, like, I don't know, this one doesn't really have any trend. So it's pretty nice to have, and you can get a pretty good glimpse of how your data looks like. So the name of the method is pd.plotting.scatterMatrix, or you can just simply import it first, like from pandas or plotting import scatter matrix, and then just run scatter matrix. But don't forget to pass in what fixed size should be, because by default pandas plot is going to be very small, so you want to make sure that it's bigger and legible. On to column manipulation. There's a number of ways to manipulate your columns and rows in Pandas. The first thing you can do is access a column or multiple columns. So for example, consider that I have this data frame df, and I want to access the 2 columns fixed acidity and pH. I have to use the square brackets for indexing, and then inside I can pass in whatever I want. I can pass in a list, or I can pass in a single string. If I pass in a single string, such as pH, it will only select the pH column and will output it as a series. If I put extra square brackets around it, it's not going to become a series, but it's rather going to be a data frame with one column. So if you use 2 square brackets, it's going to be a data frame. If you use 1, it's going to be a series. I can add in, let's add in again fixed acidity. And now you see I get this as well, and you know, they're beautiful numbers, beautiful, and it's much better than Excel. Because for example, you can say, let's say, dot sum, and bam, you're done. You have the sum for each of these elements. You have pH, the sum is this, and fixed acidity, the sum is this. You can also access the row. So let's say I want to find the first row element, I just do df.iloc 0, and I get the first row itself like this. Easy peasy lemon squeezy. And I can access multiple rows by just passing in a list instead of a number. So if I pass in a list, you see here I get the 0, the second, and the fourth row in that data frame. Similarly, you can also convert columns in Pandas data frames. So they actually make it super easy for you to do that, and you just do pd.toDatetime, your column here, and it will just automatically convert that column to a date time. You can get the time, the hours, the seconds, and perform calculations on it with it fully being parsed as a date instead of a string. You can convert it to a categorical feature like this, and some machine learning libraries will be able to pick that up and automatically do like all the training for you. Or you can just do .toNumeric to convert from a string to a number. To continue demonstrating Pandas, I'm going to be using this dataset called just Olympic history of athletes and results that I just found online on Kaggle, and I'll put a link to that in the description. So as you can see, I've downloaded and it's currently available in my JupyterLab file explorer, and as you can see, it's this data frame with IDs, with names, the age, height, weight, team, and all of that. And I'm going to be showing 2 really cool features up next, which is going to be group by as well as joins. So let's continue. So for example, if I use the group by function, I can group the athletes by their age by using this following code. And here it's going to group by age, and I'm just saying for I, athlete sub df in this, I is going to be the age of that. So let's say I say let's say at I equal 23 we break. So I'm just saying as soon as we encounter a group for which the age on all the data frame is 23, let's stop it because I just don't want to have too many print statements. So once I print this, you see that this is one data frame with just one row. This is another data frame, this is another one, this is another one, and another one, and another one, and another one, and another one. So as you can see, the ages are grouped by. So here, they're all 11, here they're all 12, here they're all 13, and here they're all 14. So you can do some pretty useful stuff with group by because it allows you to operate on groups of rows instead of just rows individually, and I use that extensively. Now I'm also going to download the second data frame, NOC_regions, and I'm just going to show how merge works. So let's just download it and I'll be right back. So let's see how we can merge this. I have written the code already, and basically you pass in the first data frame, the second data frame, and you say on which column are you going to merge by. Here I'm going to merge by NOC, which stands for the National Olympic Code, and I'm just going to specify how I'm going to merge. So I'm going to do a left merge or a left join if you're familiar with SQL or SQL, however you want to call it, and it's just going to say for everything on the left, just match it to the right. I don't care if there's extra stuff on the right, just make sure everything on the left is filled. So I run this, and you see that this shows how many not missing elements I have, so NA. And if I take the sum, it's just going to count all the NA elements I have, and this gives me 266077. And if I look at the total number of things, I get 271116, which is more. So if I look at the proportion, 98% are just empty, but some of them do have notes. And I've looked at the dataset, and it's basically like for HKG, they put China, but they also want to put Hong Kong in the notes. So it's just to add the little step over there, little exception. And finally, I can do even more stuff. So let's look at the notes. And now I can look at the unique values by doing .value counts. Like this, and bam, I get all these notes. So I have Yugoslavia, Hong Kong, Trinidad, and as you can see, we have quite a lot of mention of Yugoslavia, 2,583 out of them. And then you have you don't see the missing values because they don't count that in value counts, but it's fine. Now you can look at what everything was in the notes and you get like the counts right next to it. The last thing I'm going to show is creating a column, and just a little quick tip too. So you can create a column by just doing merge df. I'm just adding random information, and you can just pass in a list. So let's say I have this list, and I can just pass in, let's say we do from random import random, and I just pass in a random number like this, and I do this for all of the elements in it. So for I in range merge df.shape 0. There's of course better ways to do that instead of using range, but I'm a bit lazy today, and this will do the trick. So now it added a new data frame, a new column, and if I look at haha, you see it's just a stream of random numbers, and you can do anything with it. So that's basically how you add a column. And if you want to remove a column, you simply do del merge df haha, although I don't really recommend that. So if you look at it, merge df, does haha exist? Now it says here because it doesn't exist. So you can do del to delete it. I don't recommend doing that. I think it looks a bit ugly. What I prefer to do instead is just let me just run this code again. Bam, the column is back. Instead, I prefer to do merge df dot drop, and then I do which columns I do. So columns equal haha, and I just do this, and I just say dropped df is equal to this. You can also pass in a list, so I can add in like NOC if I want to drop that too. So if I run this and I just look at dropped df NOC, bam, I have a key error because it doesn't exist. Alright, here's the last thing, or maybe just before last. Okay, I'm a student then, just bear with me. It's just going to be, once you process our data frame, how you can save it. So you can simply do drop df dot to CSV, and then you can call it just dropped df dot CSV. You run, bam, you're done, and you see I have this over here. It's over here. You see it's going to be loading, but now as you can see, it doesn't contain like the NOC that I just dropped in, and like another thing. I forgot what that dropped. So it doesn't contain NOC in the haha stream of random numbers. Oh, here are some last minute tips. I forgot to show how you can filter out a row. So let's say I have this, this merge df. Well, I can and if I look at haha, you see I get this stream of numbers, and I can select from merge df by doing this merge df haha smaller than 0.5, and bam, I get all the rows for which haha has values that are smaller than 0.5, and that's just basically how you can select columns. If you want to put multiple selectors, you can just do and what I can do and merge df, let's say age equal to 23, and you see it doesn't work, so I'll be back. So here's the fix. You add in parentheses, but before doing the and it's just 1%, and you're good to go. So make sure to add parentheses in your conditions. We're just going to go bonkers and give you some errors. And finally, the last one is dot apply and iterrows. So I can create a new column based on something by just putting a function. So I can do, for example, merge df age dot apply, and I can pass in any functions. I can just say a lambda function, or look at my video over here, lambda x, and I'm just going to say x plus 1, or I can do minus x, and if I look at this, you see it just negates all these elements. And finally, one last function is dot iterrows, and it's just going to give you for I and that row in this thing, and you can just print that row, print I, and I'll just break when I is equal to 10. So you can see you get each rows like this, and you can access each column by doing like row name, row sex, row age, like row age, print row age, and bam, you get the age over here. It's not pretty, but basically with iterrows you can iterate over rows. And the last thing you'll need is, if you want to convert this data frame to a NumPy array, you can always just run dot values and it will convert it to a NumPy array. So if I do merge df dot values, bam, I get a NumPy array, and you're good to go on whatever you want to do with NumPy. That's it for Pandas. Hopefully you enjoyed this video, and I'll see you on another video on maybe transformers Or maybe I'll just pick back again neural networks. I'm going to re-explore them again and just finish my neural networks explain playlist by showing how you can code a neural network from scratch in Python and NumPy only. So stay tuned for that, and bye bye.